In this lesson, I just want to re-emphasize some of the concepts that Professor Messenger presented in his video. So first, the exponential function with base b is defined by f of x equals b to the x, or y equals b to the x. So when we have the x in the exponent, it's called an exponential function. B is a positive constant other than 1. Because 1 to the x would just mean 1 to any power. Well, 1 to any power is always equal to 1, so it's actually a linear function. So b is going to be greater than 0, but b is not equal to 1, and x is any real number. Okay, so we can plug in any number for x in order to get our answer. Along with our general exponential function, Professor Messenger also mentioned the natural base exponential function, which is given by f of x equals e to the x, where e is a constant, which is approximated by 2.71828187, and actually that goes on forever, ... It's irrational. And where that comes from is as n goes to infinity, or n gets really big, y equals 1 plus 1 over n raised to the n approaches y equals that constant e. And we're going to be seeing that y equals the 1 plus 1 over n raised to the n in a different form when you get to the compound interest formulas. So it's important to kind of understand that where the exponential function comes from is saying, okay, we can make n as big as we want, and what happens is that as we get bigger and bigger and bigger and bigger, we get close to that value of e, that constant. So that is your natural base function, e to the x, where e is a constant. Similar to how pi is a constant, e is also a constant. So now I just wanted to go through 2 examples on how to evaluate exponential functions, especially how to use your calculator if you're not sure how to do that. So right now we have our first exponential function would be f of x equals 3 to the square root of x. So why don't we just start with doing f of 4. If I'm evaluating f of 4, that means I would have 3 raised to the square root of 4, just substituting x equals 4 in. If we evaluate this by hand, we'd be doing the square root of 4 first, which would be 2. So that becomes 3 to the second power. Well, an exponential function means 3 to the second means you're doing 3 times 3, or you could probably do that in your head, is going to end up being 9. Let's try a negative number. So if I did f of negative 9, for example, that means I would be evaluating 3 to the square root of negative 9. Well, again, first we would need to evaluate the square root of negative 9, but what is the square root of negative 9? Well, it's a non-real answer, because we would actually get 3i, and we can't evaluate that then. So what happens here is that we get a non-real answer, or we can say that it's undefined. Either answer is fine. If you're working through this in your calculator, we would, let's see, if we do f of 4 in our calculator, 3 to the square root of 4, we can do this all at once. So you would first type in the 3, then you would find the caret, which is right above your division sign. So that would be 3 raised to, that'll put the next part into the exponent. Then we need to get the square root. In order to get your square root, you have to actually do second and then x squared, and that will get you the square root. So 3 raised to the square root. When you do the square root, depending on how old your calculator is, it might either open a parenthesis for you, or it might actually have the square root where you could type the number underneath. If it opens the parenthesis, just remember at the end you're going to have to close the parenthesis. So some will and some won't. So we would do the square root of 4, close the parenthesis if it needed to. If you didn't have a parenthesis to start with, don't worry about it. And then you would just hit enter, and we should end up getting that same answer of 9. If you test out the 3 to the square root of negative 9, you should actually get an error message that says non-real answer on your calculator. So next we want to find we are given g of x equals 4.9 e to the x. So remember, e is that natural base function, so it's a constant, and we do have an e button on our calculator that we're going to have to use in order to correctly solve this problem. So why don't we try g of, why don't we do 4 again? So that way we're doing 4.9 e to the 4th. So at this point, I would say to plug this into your calculator. So off to the side, we would be doing in your calculator 4.9 e. So in order to get your e, you would have to hit the second button. and your e to the x is above the ln, which you're going to be learning more about in the next section. So in order to get the e, you have to hit second ln. You should see e to the x above it. And what should happen is that, again, either it's going to show up with an e with a caret already there and a parenthesis, or it'll have an e and it would already raise it into the parenthesis. And then that way, it would just raise it into the exponent, and then that way you can just type in the number. So in our case, we're trying to find g of 4, so we want e to the 4th. And then if it did open the parenthesis, you would need to close it and hit enter. And when you do that, you're going to get a decimal, because remember that natural base function e is a decimal. And you should get something about 267.5309352. And just remember to look if where you're supposed to round it, or if they wanted rounded, how many digits to go out to. Let's try a negative number for this one. I'll go a little bit smaller. Let's try g of negative 3. So we would have 4.9 e to the negative 3. If I were to work this out by hand, at least one additional step, knowing that negative exponent, we can rewrite this as 4.9 over e to the 3rd. It is not required to write it that way because, again, we are going to just end up using our calculator. So you do the same exact steps that you had before. You could do 4.9 e to the negative 3, get your answer, or if you're plugging it in the way that I wrote it here, you would have 4.9 divided by e to the positive 3. Either way, when we get our answer here, we can evaluate it. It is defined because we can do e to the negative 3. Again, it just turns into a fraction with the e to the 3rd in the denominator. And this would be about 0.2439566635. So just make sure that you understand how to type them both into the calculator using the E button, E to the X button, and also using the caret. Finally, I just wanted to mention some properties of exponential functions. So this will be true for all of our exponential functions. The function that you see in this graph here is f of x equals 2 to the x, but all of these properties will be true for f of x equals e to the x, or more generally, f of x equals b to the x. First, as we saw from really the definition, is that the domain of this function would just be negative infinity to positive infinity, because as long as we just have an x in the exponent, we can plug in any value, and negative exponent means that we would turn it into a fraction like we saw with part B from the last problem. So our domain is negative infinity to positive infinity. If we look at our range, then remember we're looking our smallest y value to our largest y value. Looking at the graph here, we can see that it definitely goes all the way up to infinity, so we know that we're going to end at infinity. But it starts just above 0. So what happens is that we don't include 0. So although this graph might look like it's touching the x-axis, it's actually not. It's riding really close to it, because what it has is that y equals 0. It has a horizontal asymptote. So we can draw that in here in order to show that the graph does not cross that horizontal asymptote of y equals 0. Okay, so all exponential functions, as long as it's of that form, f of x equals b to the x, has a horizontal asymptote at y equals to 0. Next, what is also always true of our exponential functions is that when we find f of 0, well, that means that we would be doing b to the 0. Well, anything to the 0 power is equal to 1. So any positive constant, as we had here, to the 0 power is equal to 1, which means that the point, this is an ordered pair, 0, 1, is always on the graph. And we can verify that with what we have here, is that we can see the graph is going through the point 0, 1. If b is greater than 1, the graph of the exponential function is going to be shooting up. So like we had here, our b is 2. So 2 is greater than 1, so the graph shoots up. It's considered to be an exponential growth function. If our graph is facing downward, that means that our value of b is between 0 and 1, so something like 1/2 to the x would have that sort of shape. Still going through the point 0, 1, all the other previous properties are still true. Finally, f of x equals b to the x is considered to be a 1-to-1 function, which means that it has an inverse. Remember, in order for a function to be 1-to-1, it means that our y values cannot repeat. Each x goes to 1y, each y goes to 1x, and we test it with the horizontal line test. So as we can see here, each horizontal line that I draw through f of x equals 2 to the x only goes through the graph once. Even as we get really close to that horizontal asymptote, it's still true that we only are able to draw a horizontal line through the point once. As I said, is that exponential functions do have an inverse, and you're going to be learning more about that inverse in the next section.